Hi, in part 2 of section 12.2, which our topic is u substitution, we're going to look at two examples of antiderivatives or integrals where we are going to use u substitution to evaluate this integral. Okay, so our first example is the integral of 3x times the square root of 5 minus x squared. And so right away what I notice is that I have something fancy underneath a square root or being hugged by a power. So maybe the first thing that I'll do is I will rewrite that square root so that I have the integral of 3x times 5 minus x squared raised to the 1/2. Instead of a square root, I have a power of 1/2 dx. Okay, so we're going to be doing a u substitution because I have fancy stuff inside parentheses being raised to a power. And step 1 of a u substitution is to choose our value for u. And the way that I pick my value for u is that I look at the integrand, the function between the long stretched out s and the dx, between the integral sign and the dx, and I look for the most complicated part. In this case, I would say that the most complicated part is this 5 minus x squared all raised to the 1/2. So my choice for u is going to be the inside of that complicated part. And so my choice for u is 5 minus x squared. And I'm going to circle that because we're going to come back to that later. So step 1 is choose my value for u. Step 2, so step 1, choose u. Step 2, find a derivative. And so our derivative of u, we're going to use that Leibniz notation, so our derivative of u is du over dx, and our derivative of 5 minus x squared will be negative 2x. Okay, so we found our derivative, and our next step is to solve this equation on the side, this du over dx equals negative 2x. We want to solve that equation for dx. So to do that, that means that what I need to do is I need to multiply both sides of this equation by dx. And the reason I want to do that is because this allows me to cancel dx on the left side, and it leaves me with du equals negative 2x dx. So I've gotten the dx out of the denominator, and now I'm going to divide both sides by negative 2x. And this will get dx completely by itself. Okay, so on the right side we have dx, and on the left side we have du over negative 2x. And that piece is important, so I'm going to circle that as well. Okay, so step 1, we chose our u value. Step 2, we took a derivative. We solved for dx. Our next step is to make some substitutions. So step 4, we want to make our substitutions. And so what that means is over in our integral, back into the original integral, we have our work off to the side, and then we have our integral over here on the left. I'm going to replace the 5 minus x squared with u, and I'm going to replace dx with du over negative 2x, because that's what we solved for. We said that dx is equal to du over negative 2x. So we have the integral of 3x times u to the 1/2 times, instead of dx, I have du over negative 2x. Okay, so we have now made our substitutions, and our next step is step 5, which is we want to clean up this mix of x's and u's that we have. Now, right now we have a mix of x's and u's. We started entirely in terms of x's, and our goal is to write things entirely in terms of u. So step 5, we want to clean up and cancel all terms with x's. Okay, so some things that I see are that I have everything in here in this integral is multiplied together. So I have an x in the numerator and I have an x in the denominator, so I'm going to cancel those. And then that -2 that's left in the denominator, I'm going to bring that to the front and push it together with the 3. Now, the 3 is upstairs in the numerator, and the -2 is downstairs in the denominator. So I have 3 over -2, and then u to the 1/2 du. Okay, so we have now completely transformed our integral from x's, when we started, entirely transformed into the variable u. So we have done the u substitution, and the whole purpose, the entire purpose of doing this substitution is that now we can find an antiderivative. And I write this step in capital letters because antiderivative. I write this all in capital letters and underline it a couple of times because this is the most common step to forget. You get so excited about transforming everything into u's and then you forget to take the antiderivative, which is the whole point of doing this in the first place. Okay, so our antiderivative, I'm going to add 1 to the power, so our power is 1/2. When I add 1 to 1/2, I get 3/2. And then I'm going to divide the number in front by the new power. So my number in front is, I have a -3/2, and I'm going to divide that by the new power. So I have -3/2 divided by 3/2, u to the 3/2 plus c. Okay, so we've taken our antiderivative. I'm going to clean up this number in the front here, this -3/2 over 3/2. You can check it in your calculator, but what that comes out to be is a value of -1. So we have -1 u to the 3/2 plus c. We are now one tiny step away from writing down our final answer. So after we have found the antiderivative, our final step is to replace our u with its original value. So one nice thing is that I have, let's make this a little smaller. One nice thing is that I've circled this u equals 5 minus x squared, so it's easy for me to find that again, because now that I'm down to my last step, I have -1. My u is 5 minus x squared, so I have -1 times 5 minus x squared raised to the 3/2 plus c. So here is my antiderivative. If I were super excited about this, I could check this by taking an antiderivative. So, did I just say that? That's not what I meant to say. If I was super excited about this, I could check by taking the derivative of what we got. So in other words, taking the derivative of -1 times 5 minus x squared raised to the 3/2 plus c. And if I take the derivative of that, I had better get back what we started with up above. I had better get back 3x times the square root of 5 minus x squared. If I don't, then something probably went wrong. Alright, so let's take a look at another example. So this is the second example in this part, and here we have the integral of x plus 1 times the cubed root of x squared plus 2x dx. We want to find the antiderivative of this complicated looking function in the middle. So the first thing I'm going to do is I see that I have a root, and so I'm going to rewrite that root as a power. So I have the integral of x plus 1 times x squared plus 2x raised to the 1/3, because a root of 3 means I have a fraction with a 3 in the denominator. And then I have a dx at the end. Alright, now looking at this function between the integral sign and the dx, I see a lot of stuff going on. Most importantly, I see that I have two functions multiplied together, and one of the functions has a power on it, so I have fancy stuff raised to a power. There's a lot of things going on here. I see that fancy stuff raised to a power. That suggests that maybe I want to do a u substitution. So my first job is to choose a value for u. And my choice for u, looking at everything that's going on here, I'm going to choose as my u x squared plus 2x. And that's a sensible choice because that is the function that's the inside function of the most complicated part of this integrand. Now I will say, if you choose something different, like let's say you chose x plus 1, and you tried to do this u substitution, what would happen is that you wouldn't be able to cancel all of your x's. So maybe you should try that and see what happens, but what you're going to find out is that you're not going to be able to cancel all of the x's in your integral. Okay, so we have our value for u. Our next step is to take a derivative. So the derivative of u is du over dx. The derivative of x squared plus 2x is 2x plus 2. And now I want to solve this equation for dx. So my first step is to multiply both sides by dx. And so that leaves me with du on the left side and 2x plus 2 dx on the right side. And then I want to divide by 2x plus 2. The whole goal here is to get dx by itself. So what we now have is on the right side we have dx, and on the left side we have du over 2x plus 2. And this is an important piece of information, so I'm going to circle it. And now I am ready to go back to my integral. Okay, so in this integral, I'm going to make two substitutions. I'm going to replace the x squared plus 2x with u, and I'm going to replace the dx with what we found dx to be equal to. I'm going to replace dx with du over 2x plus 2. So that's going to give me the integral of x plus 1 times u to the 1/3 times du over 2x plus 2. Okay, so I've made all of these substitutions, and at this point I have a mix of x's and u's, and I want to make sure that my integral is entirely in terms of u's and I no longer have any more x's. And right now, the way that it looks like I may not be able to do any canceling, but what I can do is I see that 2x plus 2, and there's a common term there, and that's the term 2, and if I factor it out, check out what I'm left with. Instead of 2x plus 2, I have 2 times x plus 1. So let me write this out kind of nicely here. I mean, you may not want to write this extra step, but I'm going to choose to do it to just kind of make this hopefully a little bit more clear. We have the integral of x plus 1 times u to the 1/3 times du over 2 times x plus 1, because I factored that 2 out of 2x plus 2. This is cool because now I have an x plus 1 in the denominator and an x plus 1 in the numerator. And so those guys actually cancel, and what that leaves me with is the integral of u to the 1/3 times du over 2. Okay, life is getting better. And the reason that life's getting better is because we've gotten rid of all of the x's. I'm almost ready to take my antiderivative. One final cleanup step is that I'm going to move that 2 to the front. I'm going to kind of push it toward the integral sign. Now when I do that, because that 2 was in the denominator, I need to keep it in the denominator, and I need a placeholder of 1 for the numerator. So I have the integral of 1/2 u to the 1/3 du. Okay, I am now ready to find an antiderivative. Everything is in terms of u, and everything looks nice and cleaned up. So my antiderivative, and I'm going to write that on here, find the antiderivative. To find that antiderivative, I'm going to add 1 to the power, so I have u to the 4/3, and then I'm going to divide the number in front, that's the 1/2, by the new power of 4/3. So I have 1/2 over 4/3, u to the 4/3, plus c. And you can use your calculator, and you should double check in your calculator that when you take 1/2 divided by 4/3, that what you get is 3/8. If you're not sure how to do that fraction division in your calculator, stop in by Zoom office hours and chat with me about it. Or talk to Ryan and chat with him about how to do that. So we end up with 3/8 u to the 4/3 plus c. We've now taken our antiderivative, and our very final step is to replace u with what u is equal to. And luckily I've circled that. U is equal to x squared plus 2x. So we have 3/8 times x squared plus 2x raised to the 4/3 plus c. And this is our final answer. And what this tells us is that the derivative of that final answer should be equal to the original function that we were given at the very top. So if you want to, you can check this by taking the derivative of the thing inside the box to get the function that we were given that's circled in yellow up in the left-hand corner. Okay, I know that these can be a lot of math. Follow the steps, and if you get stuck, try it again, stop by office hours, ask lots of questions. Okay, thanks for listening.